All right, 9-4 practice. Before we jump into this, let's just kind of talk about the general formula for an area of a trapezoid. If you have a trapezoid, and I'm just going to kind of draw some generic one here, the key things that you need is you need that top base, base number 1. You need the other base, base number 2. And then you also need the height between the two bases. All right. Sometimes it's turned sideways. For instance, like number 3, your bases are turned sideways. So you got to kind of look for that. But the formula looks something like this. It's basically you add up the two bases, chop it in half, and then multiply it by the height. And that's kind of the general formula for the area of a trapezoid. And actually this first piece right here just ends up being like this expression is just you're averaging the bases. So it's just the average base multiplied by the height. You know, like rectangles are base times height. Trapezoids are like a funky rectangle because you have two bases that are different. So you need to average the two. So that's kind of going to be how I approach these problems here. All right, so looking at number 1, looking at what I have the top base, I have the bottom base, I add those together, divide it by 2, and then I multiply that by the height, which is 10. So 16 plus 9 is 25 divided by 2, that's 12.5 times 10. So just moving the decimal one place, that would be 125 feet squared, or square feet. Number 2, base number 1 plus base number 2, all chopped in half, times 7.5. So that's 31 divided by 2, which would be 15.5 times 7.5. Let me cheat here and bring up my little calculator. Can slide him over. So turn it on. 15.5 times 7.5 equals, looks like 116.25. All right, moving on to number 3. My two bases are 4 and 13. So remember, these ones, the bases are kind of going vertical, and the height is actually drawn in right there between the two bases. Also realize the height always is going to have that 90-degree angle shown in it to show that it's the true distance between the two bases. All right, so back to the equation. Average the two bases, multiply it by the height. So that's 17 divided by 2, which is 8.5 times 7. That's 56 and 3.5. So I believe that's 59.5 yards squared. All right. Heading on down. 6, 7, and 8. Find the area of each trapezoid. If your answer is not an integer, leave it in simplest radical form, so we don't have to worry about getting decimals if we don't want to. So these ones are a little bit trickier because we don't have everything we need. So looking at the first one, you know, I have my top base, I have my bottom base, so that's all good. But then when I go to multiply by my height, I'm missing the height. I don't have it. So we're going to need to figure out what number to put in here for my height. And a clue that I can use is I can use this triangle off to the right. So if you notice, since this top piece is 8, that means that this piece would also be 8. And if the whole bottom down here is 18, you know, they told me that this whole piece was 18, that would force this other piece over here to be 10. So now I know 10. So now I have a triangle where I know 2 out of the 3 sides. And so I'm just going to use Pythagorean theorem, which remember is leg squared plus leg squared equals hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. So that'd be h squared plus 100 is 121. Subtract from both sides. So h squared is 21 when I subtract 100. And then the square root of both sides. And I'm just going to leave it. I'm just going to leave it as a square root of 21. And I'm going to plug that back in up here. And so now when I multiply this out, I'm going to have 26 divided by 2, which is 13. And then I'm just going to bring the radical 21 down. And this is my answer in simplest radical form. Now, if I really wanted the decimal, I could bring the calculator back up, and I could multiply it out, and I could do 13 times radical 21 equals, and get 59.57 or 59.6. So if we really needed to, that would be an approximation. All right, next problem, looking over here at number 7. So I'm going to kind of use the same trick. I have 11 at the top, so this is going to be 11 at the bottom. So I have 11 there, which tells me that this entire base down here is 13. So now I have my two bases. So when I go to do the actual equation, I have top base plus bottom base chopped in half. But again, I'm missing that doggone height. So I'm missing this h. So I'm going to focus on that triangle again and do Pythagorean theorem. So h squared plus 2 squared equals 6 squared. So that's h squared plus 4 equals 36. Subtract 4 from both sides. I'll get h squared equals 32. And then take the square root. And a couple different things. I could change it to a decimal right now. Alright, so breaking down the square root of 32, I try to find a perfect square. My numbers that are perfect squares, remember, are like the square root of 4, square root of 9, square root of 16, square root of 25. Those are called perfect squares because the square root is a whole number. So I see that I could get the square root of 16. So the square root of 16 times the square root of 2 would be the square root of 32, which is just 4 radical 2. So this is what would be considered simplest radical form. So now I would need to go and put that h up here at the top. 4 radical 2. And again, if I wanted to, I could just get the decimal for the square root of 32 and plug that in there. But just trying to do simplest radical form here. So let me kind of get rid of these. And let's go ahead and finish it. So 11 plus 13 is 24, divided by 2 is 12. So I have 12 times 4 radical 2. And when you multiply radicals with numbers, you can only do the two whole numbers out front. So that would be 48. And then the radical 2 is just going to come along for the ride. Now, if you do it the decimal way, you're going to end up with 48 times radical 2, which would be 67.9. So if you did it the other way, you're going to get 67.9. So either one of those answers would work. All right, number 8. Quite a tough problem here. I'm going to put a star here. If you don't quite master this problem the first time through, hey, this is a tough one because we're missing lots of pieces. If you notice, I'm missing this bottom piece, so I don't have base number 2. I'm also missing the height. Now you might look at this and think it's a square, but it turns out it's really not. So your eyes might kind of lead you astray on this one. So let's kind of battle through it and see what we can do. So to get both of those pieces, the first piece I'm going to go after is I'm going to try to go after this height right here. So to get this h, I'm going to use the fact that this is a special right triangle. So this triangle has a 90 and it's got a 30 right here, which means there's a 60 right here. So since the hypotenuse is 10 on a special right triangle, I know that the shortest side, the shortest leg, is exactly half of that. So that's 5. And I also know that the middle leg is 5 radical 3. Now, if you didn't know that, you could have used SOHCAHTOA. You could have put your guy right here at the 30-degree angle, and you could have called this x, and you could have called this y, and used sine, cosine, or tangent to solve it. but the special right triangle rules are a little bit faster. So let me kind of put in what we now have. So I'm going to get rid of this h, and I'm going to put in here, we know that the height is 5, and we know that this piece right here is 5 radical 3. And let's just go ahead and get a decimal for 5 radical 3. 5 radical 3. It's about 8.7. So I'm going to write down 8.7 right here. So if that's 8.7, I should be able to figure out this piece because those two numbers have to add up to 14. So 14 subtract 8.7 would be about 5.3. So it's kind of close to being a square, but not exactly. All right, now I think I got enough information to solve the problem. So top base is 14, bottom base 5.3. Got to divide that by 2. And then I need to multiply that by the height. So what do we have? We have 19.3 divided by 2 times 5. Let's cheat and use our calculator again. So 19.3 divided by 2 times 5 gives me a grand total of 48.25. That was a tough question. So, and the units would be centimeters squared. Tough question there for number 8. All right, moving it back down, number 9. I think we get a little bit easier here. So area of a kite, quick little refresher. It's basically just diag number 1 times diag number 2, all times 1/2, or all divided by 2. So it's 1/2 diag times diag. So if I look at this, the first diagonal is 8. The other diagonal is 2 plus 6.5, which is 8.5. And then I need to multiply that by 1/2, or 0.5. So 64.5, let's see. That'd be 64 plus 4, it's 68, chopped in half. Leave a grand total of 34 feet squared. Let's try number 10, kind of using the same idea. So I have 6 times 8, which is 48, times 1/2, or times 0.5, would give me 24, and that's centimeters squared. Looking at number 11, I have 15 times 12 times 0.5. So 15 times 12 is 150, and 30 is 180. Half of 180 would be 90 meters squared. And please let me know in the comments if I screw up, because I'm doing some of these in my head. Some of them I'm not pulling up the calculator. So if I screw it up, give me a shout. Let me know in the comments what I'm doing wrong here. Whoa. Besides making this problem way too big. All right, number 14. Things are getting a little tougher here. I don't quite have enough information, mainly because this 22, the way that it's pointing, I think it's only representing this piece. And I think the 25 is only representing that piece. So what I need to do is I need to kind of double that, because remember, in a rhombus, I need to know the properties of a rhombus. A couple things. One thing is the diagonals are perpendicular to each other. All right, so these are all 90s when you're in a rhombus. Another thing is the diagonals bisect each other. All right, they don't in a kite, so the problems up above, the diagonals did not chop each other in half. One of them do, but in a rhombus, all 4 of them do. So I can kind of use that information to figure out that this piece is also 25, and this piece is also 22. So now I have one diagonal times the other diagonal times 1/2, or 0.5. So half of 44 is, actually I'm going to go half of 50 is 25. And then times that by 44. 25 quarters would be $11. So 1,100 feet squared. Hopefully my mental math isn't screwing me up there. Number 15. Ooh, this one's a little trickier. So this one I have a 4, which tells me that this side is 4. But then they don't give me anything on the other diagonal. You know, this red diagonal over here, they give me nothing. I have nothing going on there. So what I'm going to do, let me just make this 4 a little bit clear. What I'm going to do is I'm going to call that X. And I'm going to use this right triangle right here because the diagonals are 90 degrees. I'm going to use that right triangle right there. And so I'm going to write this out. I'm going to go leg squared plus leg squared equals hypotenuse squared. And that's going to be x squared plus 16, 36. Subtract 16 from both sides. X squared is 20. So square root both sides. X equals radical 20, which what is radical 20? Let's just check that out. So square root 20, boom. 4.47. I'm going to kind of leave that in because it's not the final answer. And actually, if I wanted to be really exact, I could just leave it as a radical. Maybe I'll do that just to show you how you can do that. So that means that this diag right here is radical 20, and this diag is radical 20. So when I add a radical 20 plus another radical 20, I have 2 radical 20s. So if I want to do this formally, I would say 2 radical 20, because that's this whole diagonal. The blue diagonal is pretty easy. That one's just 4 plus 4, which is 8. Then I need to multiply it by a half, because that's what the formula says. Half of 8 is 4. And then 4 times 2 radical 20. Well, you can only multiply numbers with other numbers, not with a radical. So this is going to be 8 radical 20. So if I needed a decimal, 8 times radical 20 is about 35.8. So that's a pretty good approximation. Also, if you wanted to keep this as simple, a simplified radical, you could break down this square root of 20, and that's the square root of 4 times the square root of 5, which is 2 radical 5. So this I've now changed. So 8 times 2 radical 5 would be 16 radical 5. So this would be if you wanted to actually have it perfect and not be an approximation. All right, looks like I got to get rid of some stuff here to make room for number 16. So similar idea, I believe, on this one. We do have this whole radical, or this whole diagonal. So I know that diagonal is 10. I'm missing the other diagonal, and I know it's going to be a half. So what we need to find is we need to find this joker right here. Well, I'm going to kind of use the same idea, but I'm going to work backwards on this one. So since the whole blue diagonal is 10, each side is 5. So that's 5. This is 5. And now my x is going to be down here. So same thing, since this is a right triangle, I'm going to use Pythagorean theorem. X squared plus 5 squared equals 8 squared. X squared plus 25, 64. Minus 25 from both sides is going to be x squared equals, I believe that's 39. And so x is going to be the square root of 39. Now, since I have 1 here and I have 1 here, I need to double that. So I have 2 radical 39s. All right, so let's multiply all this out. I got the numbers. So 1/2 times 10 is 5, times 2 all comes out to be 10. And then the radical 39 just comes along for the ride. And now if I wanted the decimal, 10 times radical 39. Boom. 62.4-ish. There you go. All right. 21. Let's see how much. Boy, we got quite a decent amount. What the heck was I thinking when I made this assignment? This thing's long. All right. Let's go in here and let's battle. Although these ones look quite a bit easier, at least in the start. So let's get rid of this. And number 20. Trapezoid has 2 right angles. 2 right angles. So that means it must look like this. I think that's the only way you can have 2 right angles. 16 inches and 20-inch bases. So I have a 16 and a 20. 5 inches of height. So we have a height in here of 5. Sketch the trapezoid and find its perimeter and its area. Well, the area would be pretty easy. You know, the area here is just going to be base 1 plus base 2 chopped in half times the height. So that's 36 divided by 2 is 18 times 5, which would be 90. So there's the area. Perimeter is going to be a little bit trickier. Perimeter, I do know that since this line is 5, this line is 5. So 3 of the sides I could lock down. 16 plus 5 plus 20. But what I'm missing is, I seem to be missing this piece right here. So that's what we got to try to figure out. I could use Pythagorean theorem. Since the top is 16, this bottom piece is 16, which makes this piece 4. And so now doing Pythagorean theorem, I'm going to have to write down here 4 squared plus 5 squared equals, and remember this is the hypotenuse, so I got to do hypotenuse squared, or I don't know squared. And we get 16 and 25, my first football number, 41. So let's just leave that as the square root of 41. And so now I can kind of write that right here. And if I'm going to add up all the sides for the perimeter, I have 16 plus 5 is 21, plus another 20 is 41, plus the square root of 41. Oh, that's kind of weird. But this would be our perimeter if I was leaving it in radical form. If I want to find out the decimal for that, 41 plus square root 41, 47.4. So the perimeter, 47.4 for that one. All right, let's get rid of this so we got some room to work. Moving things up. We're not going to worry about leaving radicals in anymore. I'm going to try to speed this up a little bit by getting just decimals and rolling with that. So number 21, I have base, so 7 plus 10 chopped in half. Looking for the height. I believe we already did this up above, 2 and 6. Yeah, that one's over here. We already did that. 2 and 6 came out to be looks like I kind of erased it. Don't know where it went. So I guess we'll have to do it again. Doggone it. Height squared plus 2 squared equals 6 squared. So that's 8 squared plus 4 is 36. 8 squared is 32. So square root both sides. H equals, it's probably up on my calculator screen if I could go up on it. 5.65 we'll call it. So we're going to times this by 5.65. So that's 17 chopped in half, which is 8.5 times 5.65. Like 48.025. And that would be inches squared. Next one over here. Let's see what we got. Man, these are getting tough. So I have a bottom base of 15. I know that. I'm missing a top base. And I'm also missing a height. So I'm going to use my special right triangle trick. So the freak leg is 8. So I know that working backwards, you can divide by radical 3. So this height is 8 divided by radical 3. So let's just get that right now. 8 divided by radical 3. 4.6. So there's the height. And to get this side right here, the relationship is whatever the short leg is, you double it. So we're just going to call this 9.2. Well, these answers are off a little bit because I'm rounding, but oh well. So if that's 9.2, I should be able to subtract from 15 to get this other side, which would be 5.8, which would make this top 5.8. Now I think I got what we need. So base 1 plus bottom base chopped in half, all multiplied by the height. So this is 20.8 divided by 2 is 10.4 times the height. 10.4 times 4.6. 47.84. All right, 23 is looking like a rough one too. Let's see what we got going here. I do have one base, and actually the bottom base, they give me the whole thing here too. That's 4.8. So far, I have 1.8 plus 4.8 chopped in half. Basically, all I need to get is that doggone height. So trying to figure out this. The nice thing is it's a special right triangle. It's a 45, 45, 90. So if you know this hypotenuse, this side is just going to be the hypotenuse divided by radical 2. So the height's just going to be, whoop, check that. It's going to be 4 divided by radical 2. So let's bust that out. 4 divided by radical 2. Boom. 2.8. Roughly. Alright, so 1.8, 4.8. That is 6.6 chopped in half is 3.3. All multiplied by 2.8. So 3.3 times 2.8 equals 9.24. About. Realize these are all about once you start rounding stuff off. All right, number 10. So this one I got to work backwards. They give me the final answer, but I got to work backwards to figure out what's going on. So, you know, realize that for all of these, it's diag number 1 times diag number 2 times 1/2 or 0.5 equals the area. So right now I have 15 plus 15, that's 30. Now maybe you assume the whole thing was 15. I could kind of see that, but The arrow kind of makes it look like it's just one little part. Diagonal number 2, we don't know. So I'm going to just call that D right now. Times 0.5 equals, and then I know what A is, so I can put that in here. So now we just got to solve this equation. Well, when I solve the equation, 30 times a half is 15. So I have 15D equals 330. And divide both sides by 15. That means the diagonal looks like it goes in there 22 times. So that means that this entire diagonal, this whole thing right here, is 22. But I only want this part of it. So I got to chop it in half. So x equals 11 be your final answer. All right, let's do this number 11 over here. I have base 1. I have base 2. So I'm going to go base 1 plus base 2, all chopped in half, times the height, which we don't know, comes out to be 196. Well, I can kind of clean up this first part right here. If I focus on just this piece, that's 449 divided by 2, which 49 divided by 2 is 24.5. So 24.5 times x is 196. Now I need to divide both sides by 24.5. So 196 divided by 24.5 equals, get an answer of 8. Bam. So those two are working backwards. Kind of turns into an algebra equation. 13 and 14, these are usually pretty easy because they're on the coordinate grid. So find the area of each figure. Well, first of all, you got to know what it is. This figure over here is a kite. So basically, I got to do diagonal times a half. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 times 1/2. 24 times a half is 12. All right, over here I have 2. I have 5. So base 1 plus base 2 chopped in half. That's 3.5. And then the times by the height, that's 4. So 3.5 times 4, that's a double, which is 714. Boom. Number 28, one diagonal of a rhombus is 5 less than twice the other one. Holy smokes. What was I thinking when I made this assignment? So we have a rhombus. And in a rhombus, remember, they're not the same, but they bisect each other. So I have that one, and I have that one. Actually, I'll put it in red. Keep them straight. So find the length of each diagonal. So one diagonal is 5 less than twice the other. So I don't know anything. Let's just call this blue one x. So let's say that whole blue diagonal. So diagonal number 1, we're going to call x. Well, it says that the other diagonal, this one, is 5 less than twice the other one. So that diagonal is 5 less than twice the other one. All right. And we also know what the area is. So let's just kind of do our formula here. I have diagonal times diagonal times a half equals 75. And this thing is going to get pretty messy. We're going to need to factor it. So since we haven't done a ton of work on factoring, I'm going to just try some numbers. So let's kind of take a totally different approach to this one. Show you how I solve stuff on the SAT sometimes. So I know that diagonal times 1/2 equals 75. So first thing I'm going to do is I'm going to times both sides by 2 to get rid of that 1/2. So if I times the left-hand side by 2, it just kind of gets rid of the half. So I know the two diagonals multiply together to make 150. So let's kind of try. Let's just do a little trial and error here and try some things. Well, I don't know. I'm going to pick a number. I'm going to make one diagonal 7. And the other diagonal's got to be 5 less than twice him. So twice him would be 14, and 5 less than that would be 9. All right, so what I just did was I made sure this number was twice as big as him, take away 5. Well, now when I multiply them together, I only get 63, which I need 150, so way too small. So let's go bigger. Let's go to 10. So if I double 10 is 20, and I take away 5, I get 15. Boom, I got it. 10 times 15 does equal 150. So I believe I have the two diagonals. So I got lucky. I got that one on my second try. Sometimes it takes 3, 4, 5 tries. Whew, finally we're at the end of the sheet. Hopefully we can blast through these ones pretty quick. Looks pretty similar to what we did up above. So area of a kite, 1/2 diagonal times diagonal. So 6 times 5, which is 30, times 1/2. So the correct answer for this one is 15. 2 times 4, 6, 8 times 1/2 is 8. Oh man, look at this dude. So this dude's got some weird diagonals going on here. So diagonal times diagonal. Well, since I can't count those, since they're going cockeyed, I'm going to have to use Pythagorean theorem. So, looking at, let me just kind of focus right now on this triangle. All right, focus on that one. And actually, I'm going to undo that step. Focus on, it's a little easier to see. Focus on this triangle. Right there. Notice that the two legs are 3. And so to find the hypotenuse, it's going to be 3 squared plus 3 squared. And take the square root of that. I'm just doing Pythagorean theorem here. So it actually is the square root of 18. And let's just leave that alone for right now. So right now what I have is, kind of lasso this up, clean up my graph a little bit. So right now we know that this diagonal is the square root of 18. And the other diagonal, this blue one, is going to be, looks like the same thing, because it looks like it's another 3 by 3. So he's going to be the square root of 18. So now when I do diagonal times diagonal times 1/2, well, the square root of 18 times square root of 18 is just 18. And 18 times 1/2 is 9. So that one was a little bit messier. Alright, I apologize for how long this assignment was. This thing was no joke. Hopefully I broke it up into 2 separate days. See you.